Okay, so welcome to our afternoon session on probability, statistics, and math education. And so our first speaker will be Dr. Lucan Jen, talking about dependent patterns among exchange rates, a mixed Copula approach.
Okay, well, thank you for the introduction. Let me share my screen. All right, now I'm going to give a talk on this topic. It's about the dependence patterns among exchange rates. We are going to use a mixed Copula approach. Okay, so now the first question, in this talk, I'm going to firstly give an introduction, and then followed by the model, and then the estimation procedure, give some empirical results, and then finally we conclude the talk. Now, what is exchange rates, right? So that is a very interesting concept. Okay, so if you go international traveling, right? For instance, you go to Europe. Now you will need to buy euros, the currency used in Europe using US dollars, right? So there is a rate, and this rate is called exchange rates. Basically, it is the price of one currency in terms of another, right? So like one US dollar is 0.83 euro, it is 1.29 Australian dollar, or 105.99 Japanese yen, right? So these exchange rates plays really important roles in modern economics. So there are, different investment, different global business, and so on. Now, these exchange rates do not stay the same. They change constantly. They constantly fluctuate. Now, what is the driving power of making these changes? So it is basically a supply and demand. All right, if the supply is larger than the demand, then it's going to decrease, while otherwise it's going to increase. Okay, so you can see that these exchanges actually change every second. All right, it changes every second. If you can see it fluctuates every second. Now here I give just one example here. This is a monthly exchange rates of Australian dollar. This time period is from January 1999 to December 2020. As you can see from this graph, all right, it fluctuates, right? It goes ups and downs, and in some patterns that is very, very interesting and strange, right? So now people may wonder how they change. And if you know how they change, right, you can make a lot of money out of this, or if you can predict this pattern well. So there has been a lot of studies on modeling how these exchange rates change. Okay, of course, here we are going to talk about how exchange rates, they relate to each other. All right, so now some pairs are closely related. If you compare here, we have what? We have the Australian dollar and this euro. Okay, now if I put these two curves in one plot here, you can see their patterns are coincide with each other pretty much well, right? So if one increases, the other also increases. If one decreases, the other also decreases, and so on. So they have a very close relationship with each other. Okay, so that's very good. All right, that's something that supposed to be, because their values should be keep consistent with each other, right? Something like that. Now, where others are not like this. All right, so some pairs may have really different dependence patterns. Here you can see this is Australian dollar and the Great Britain pounds. All right. Now, initially between 1999 to 2009, they are more or less good, but afterwards, all right. So you can see, right? Afterwards, now they seems to go to different directions. They at least not as close as before. Something different. It shows something different patterns there. All right. So now it is a very, very interesting question as to how these exchange rates depends on each other. Will the increase of one affect the other? So that's the type of question we're going to talk about in this talk. All right. So as we said, there's a lot of study about how exchange rates affects each other. Okay, so there are different approaches. Okay, a lot of study are based on Gaussian assumption. All right, assumed to be normal or something like that. Now there has been a lot of studies based on Gaussian assumptions, but this is not a good idea because financial data, financial world, it is very, very complicated, right? It's not always normal. Now that's why when Copula was firstly introduced to model in financial world, it instantly attracts a lot of attention. Okay, there are many studies using Copula to model financial data. Now, why Copula? Is because it provides a lot of flexibility in the modeling. Okay, now it is the links the marginal distributions with some parameters. All right, that's what a Copula. What is a Copula? Now, Copula is basically a multivariate distribution function that connects marginal distributions through a linkage parameter. Okay, so there are different families of copulas, like the elliptical copulas, Archimedean copulas, extreme value copulas, and within each family there are also different other types of copulas. So subfamilies. All right. So there is a lot of such different families of copulas there. Now, in the past, for the study of exchange rates, most of the studies has been using a single copula family to model the dependence of different pairs of like exchange rates. Now, however, as you can see, the single family is usually not enough because especially when we talk about exchange rates, it is very complicated. And if you just one single copula family can never fit all the different situations in exchange rates. So that brought up our idea. We want to here using a mixed copula model. All right, what is a mixed copula model? All right, so this is a mixed copula model. Here we're going to introduce in the second section is the model. All right, our mixed model includes 3 copulas. All right, so they are Gaussian copula, Campbell copula, and Clayton copula. Now, of course, this mixed model is going to be a weighted sum of these 3 copulas, right, with the parameters of W1, W2, W3 are the weights, and the rho, alpha, and beta are the association parameters. Okay, so this is our model here. It has 3 components. One is the Gaussian part, this is the Campbell part, and this is the Clayton part. Okay, now why we choose these 3? Now the reason is because the Gaussian copula are usually used to capture this so-called symmetric dependence. A Gumbel copula captures the right tail dependence, and the Clayton copula captures the left tail dependence. Okay, so that's why we are talking about these three copula. They are very, very popularly used for different type of structure. If we mix these three, now this model, as at one time, on one hand, it is very simple. On the other hand, it is very flexible. It is very flexible. Now, what do we mean by symmetric dependence or right tail dependence or left tail dependence? Now, here is a graph to show this. As you can see, this Gaussian copula here. Now, it is, you can see, from this part and this part, it is about symmetric. The dependent structure is about symmetric with respect to the middle point. Okay, so this is a Gaussian, it's a symmetric dependence. For the Gumbel here, all right, as you can see that it captures more of the right tail dependence. It can also be shown in this scatter point plot here. You can see on this right tail here, when U and V are both large, they are closely related. Well, when they are small, U and V are small in this part, they are more or less randomly scattered. Okay, so that's why Gumbel copula can capture the right tail dependence. Now, finally, the Clayton copula are used to capture the left tail dependence. You can see also from these two graphs. Now, from the bottom here, you can see that when U and V are both very small, they are closely related to each other. Well, when U and V are both large, they are not related to each other much. Okay, so that's these three copula components, and that's also the reason why we include these three in our mixed model. Now, in this model, we have like different parameters, like these weights, and also these association parameters. Now, these weights and the parameters tells us something about this dependent structure, right? So weight 1, weight 2, weight 3 is the proportional structure, right? The structure play the role in this pair. And those different associations parameters tells us the strength of the dependence. Okay, so we are not talking about the strength of this dependence, but also talking about the structure of the dependence. All right, that's also very, very why the copula have an advantage over very traditional measures of dependence. Now, for this one, you can see we have several parameters, and it's really hard to do the estimation. Now, here is the estimation procedure. Now, what we do first is using Armour-Gauge filtration to filter our time series. In order to remove the sequential dependence and the conditional heterozygosity. This is very common in finance and economics, because when you have time series data, the observations tends to have a sequential dependence and conditional heterozygosity. So we use this one firstly to filter out these facts. Now, after that, we do a two-stage semi-parametric estimation of the model. Now, the step in stage 1, what we do is we estimate the marginal distributions. We estimate the marginal distributions. This can be done using an empirical distribution function and probably other methods. But this is a good thing about the copula. We can, using copula, we can separate the estimation into two stages. All right, so we can firstly conduct the marginal distributions, and then, based on these estimated marginal distributions in the second stage, we estimate those parameters. Okay, so the method we use is maximum pseudo likelihood estimation. All right, so these are the methods we use. Now here I will go to show some empirical results we have, right? The major findings we have through this study. Now we have this data is the monthly exchange rates of 6 currencies: Australian dollar, Canadian dollar, Swiss franc, the euro, Japanese yen, and the UK pounds. These are all the units of these currencies per dollar, per US dollar. Okay. Now we consider the time period is from January 1999 to December 2020. These data obtained are downloaded from the International Monetary Fund rates database. And we firstly take the log returns, and then using this Armour-Gaucher filtration to filter these series. So this gives us a table of the results of the linear correlation matrix among the filtered log returns. Okay, as you can see from this table, we can have some observations here. One here is this pair between ECHF and euro. All right, so these two has a really large linear correlation coefficient. Okay, they have a strong positive linear relation with each other, closely related. All right. Now there are also like say this one. All right, between Japanese yen and Great Britain pound. These two, the correlation, a linear correlation is pretty low, right? So they barely have any correlation there. Now, we here are talking about the linear correlation matrix, right? So whether they have some linear relationship or not. Now, of course, as we will show, exchange rates, the relationship between exchange rates are really complicated, all right, are really complicated. And we will see something about this later on, okay? So this is a graph we have after the filtration, all right? We firstly fit all these Armour-Gaucher model and select the best one based on the AIC. All right, so like these ones, we are just having the Gaucher 1-1, but for this one, we have Armour 1-1, Gaucher 1-1. All right, so these are selected using based on the AIC and BIC for the model selection. And you can see from our results here, the graph, right? The red one is empirical CDF. Well, this black one, dashed line, represents the theoretical one, CDF. You can see that our fitting after this filtration, they are almost the same. So very good, okay. Now the estimates are given here, all right? So we are using the EM algorithm. We drop a component if it is small, if the weight is very small, or it indicates some independence, all right? So as you can see from this table, now 12 pairs, all right? Among these 6 currencies, 12 pairs are with 3 components. These weights, all right, are all positive or larger than 0.1, okay? Now 2 pairs with 2 components, like this one and this one. They only have This one only have Campbell copula and Clayton copula. This is the same, all right, and the one with only one. So that's the Canadian dollar and Japanese yen. They only have what? The Clayton, which is the left tail dependence. Okay, so another observation we have here is the Campbell dependence structure play a more important role than Clayton. This can be seen from the weights. All right, if you can see, these are the weights for Campbell, and these are the weights for Clayton. All right, so for vast majority of the pairs, the Campbell has the larger weights. All right, and also the weights varies among different pairs. Okay, so these tells us something about the complexity of the exchange rates. Now here we conduct a goodness of fit, all right, test. So this one, as you can see, based on the p-values, all right. So this is to test whether our model fit the data well or not, all right. So if the p-value is larger than 0.05, that means our model works well. All right, you can see from the results, all the p-values are larger than 0.05. That is to say, our model works well, fit the data very well. Okay, fit the data very well. For all different pairs. You see that we have 6 currencies and these 15 pairs, but our model fit these pairs all very well. Okay, well, here is just to give you some presentation of our result. All right, and just conclude here. We have data on 6 exchange rate of 6 currency against US dollar. We used a mixed Copula model. It shows different dependent structures and strengths. All right, their strengths association parameters are also different. And our model fit the data well based on the goodness fit tests. All right, I think that's all for my talk. Thank you for listening.
Do we have any questions for Dr. Zhang? Was a lot of this work you were doing with Richard, a former.
Yes, this is a work I did with my previous master student. He already graduated. Yes, this is one of our previous work on this.
Where did he go?
He went to University of Colorado at Denver in the Department of Economics.
Well, we should have him for a SIAM talk, huh?
Yes.
Do we have any other questions? Okay, let's thank Dr. Zhang.
My name is Andrew Davison. This is Morgan Samples. And we're going to be presenting the project that we did for computational problem solving. It's of course computer science math 371. We had a lot of fun. We're both board game kind of geeks, and
this is a game that we played a lot. This is a board game
that we played a lot, and so we just had a lot of fun making it. And there's some pretty interesting statistics behind the AI in the game, and so we're just happy to share this with you guys today. All right, Morgan, you ready to take us away?
So what is Love Letters exactly? Well, it's a card game, and it's a card game with 8 different card variations. Each card implements a different action, and depending on what card you play depends on the direction the game kind of takes. The goal of the game is to be the only player left at the end of the round. You do this by knocking your other players out by playing different cards. There's 2 to 4 players, and like I said, you're trying to knock your other opponents out and be the last person standing. So each card does something different. This card you see to your right here is called the Raven. And when you play this card, you choose an opponent and you guess what card they have in their hand. If you guess correctly, then that opponent is knocked out of the round and you move on to the next turn. If you guess wrong, you just move on to the next turn. And like some cards have special effects. Like in this case, you can't guess the Raven for someone else. So if I played this card against Andrew, I couldn't also guess that he had the Raven. So like I said, every card does something different. Here are 3 other examples. In the case of the Pit and the Pendulum, this one, when you play, gives you immunity, or the player who discarded it immunity. And this means that no other player can play a card against you. In the case of Lenore, once you discard this card, then that ends the round for the person that discarded it. So if I played it, then I would automatically lose that round. And it's generally a good reason not to play it. For the Mask of Red Death, this is one of those instances where you can play a card against another player, which tends to be the case for most of the cards. But in this case, if I play this card against Andrew, then Andrew would have to discard his card and draw another one. So depending on what cards you play depends on how the game goes. So like in this case, so you'll start the round, everybody has dealt one card. When it's your turn, you're going to draw another card and you'll choose between those 2 as to what you're going to play. You will only ever have at most 2 cards on hand. So in this case, presumably player 1 who is playing right now has another card. He's just chosen to play the Mask of Red Death. So in this case, player 1 has chosen to play the 5 against player 2. But this action is blocked because player 2 has already played the 4 previously, which has granted them immunity from any cards being played against them. So the way the game goes depends on what you play. You're going to see this a lot when we play each other here in a second, but this is just one of those instances where the card didn't really take much effect. So the game ends, like I said before, when one player is left standing or the deck runs out of cards. So players are attempting to knock each other out by using their cards. But if the deck runs out and more than one player is still left standing, then the player with the highest card value is going to win that round. And your card values are specified up here in the corner. The important thing to note is that cards with a lesser value tend to be more frequent in the deck, like in the case with the Raven before, the 1. There's actually 5 of those cards in the deck. But with the case of Lenore, the 8, there's only 1. So you kind of, when you're strategizing during the game, sometimes it's better to keep the highest card in case the deck does run out of cards and you're still left standing.
So to kind of give you guys a feel of what the game is like, we're going to go ahead and do a little friendly game between me and Morgan, give you guys an idea of what this is like before we go into the strategy that we've put into the game. So first of all, we're going to look at the helper card that we have here and kind of go over what all of the cards do and what those look like. This is going to be really important later when we talk about how the AI plays the game, how it gives its strategy. So we've talked about the Raven already. It allows you to guess another player's card and knock them out of the round potentially. And there are 5 of those. If you see in the parentheses, that's how many of that type of card are in the deck. There's also the 2, the Telltale Heart, which lets you see another player's hand. There are the 3s. So there are 2 different kinds of 3s, but they essentially have the same function, which is that you compare. So you play the 3 and you have another card in your hand, and you compare your card with your opponent's card. In the case of the Fortunato, the player with the highest value gets knocked out. Case of Montresor, the player with the lowest value gets knocked out.
Like a lot of times we refer to these cards as like 3.1 and 3.2, just to kind of
since they're essentially the same card, we just call them 3.1, 3.2 instead of Fortunato Montresor. 4, we've talked about playing that card will give you protection for a round. A 5 will let you discard one of either yourself or another opponent's card and have them draw a new hand. A 6 will allow you to swap hands with someone else. A 7 is just a high card, but if you draw a 5 or a 6, you're required to discard it or to play it. And an 8 is the highest card in the game, and if you play it, then you automatically lose. So it's a risky card to have, but at the end of the game, it's the card you want to have. So first off, Morgan and I are just going to play a game to give you a feel for the how the game flows. Like Morgan talked about with the tokens, you can play multiple games. We won't do that right now. And hints in AI are something that we'll get into a little bit later. So we'll play this game again later once we've talked about the AI and showcase that a little bit. But right now, we're just going to be me and Morgan. So I'll be player one. I'll go first.
I won't look.
And Morgan won't look. So I draw a card, and I don't really have much of a choice here, but play the one. Like we said, the one allows you to guess another player's card. So I'll just guess that Morgan has a 5. I was wrong, which is okay, right? We want to showcase more than just the one. So now that means that it's Morgan's turn.
Okay, well, assuming I didn't cheat.
Yes.
Okay, I also have a 1. And to keep this game going longer, I'm going to play the 4 because it'll protect me from Andrew. So we'll do that. And that's your turn.
Goes back to me. So if you recall the Montresor, I can also look at the helper card as well. But the Montresor will knock the player with the lower card out of the round. I have the lower card. I obviously don't want to do that. So I'm just going to play a 1. She is protected, so I can guess, but I won't do anything. And I'll keep the 3 for the next round.
Okay. And doesn't look like I have much of a choice. But I'll guess the 3.
Yes.
Okay.
So since she guessed correctly, I get knocked out of the round. That means that Morgan's the only one left and she wins. So that's kind of just to give you an idea of how the game flows. But now we'll go back into, into a little bit of what the thought behind the game is. So Morgan.
Yeah, so like I said before, there's 8 variations of cards. And where the logic comes in here is, like we said before, there's only so many of each card in the deck, and that depends on which card it is. So in the case of Lenore, if you were to play the 8, then you would know that card wouldn't come again in the game. So like with 2 players, if Andrew were to play the 8, then the round would end, so it wouldn't matter. But if there were 3 and someone played the 8, we'd know nobody else is going to play it again. And this is where like Andrew and I worked on the helper and the AI. So the helper in this game gives you suggestions as you play and like guides you as to what cards you should choose based on the probability of that card being. So if the 8's already been played, there's 0 probability that card's going to come up again. Using the same logic, we coded an AI player that plays against you as you play as an opponent. So Andrew's going to get into what's
the AI player is pretty good. I would not be surprised if in the later example we lose. So first off, before we get into AI, I'm going to talk a little bit about what makes a good love letter player, because that's what we want to give to the AI, is we want them to be good at the game. So there are 4 quintessential things that I picked out, which is that number 1, in order to do well in love letters, you want to guess well. A lot of what you do depends on what you think your opponent has, and guessing well is just really important to that. And the second one is gathering information. And this is mainly to support the first one, which is so that you can guess better if you have more information. This includes stuff like paying attention to the cards that your opponents play, remembering what you've learned through your plays, etc. Next, we have deciding which cards to keep and which cards to play. So when you draw a card and you have 2 cards, making a good choice between the 2 of those makes someone a good player. And finally, deciding which opponents to target. Right. Recently, you just saw a 2-player game where there wasn't much choice, but in the 3rd and the 3 and 4-player games, you also have to decide which players you want to play against. And so this corresponds pretty nicely into our 3 levels of AI that we're going to talk about here shortly. The first one here is card probability. What's the probability that someone else, your opponent, has a given card? Next, we have your card choice. What card do I choose? What card does the AI choose when presented with 2 choices? And the information that goes along with that. And then finally, what opponent did they choose based on the card that they're playing? So our level 1, our probability, is divided into 2 distinct segments. We have uninformed probability and informed probability. So uninformed probability takes place when we don't have a lot of other information. We're just trying to guess. We haven't played any cards that give us any more information. And so this is pretty simple stuff. It's like stats 101, you know, if the probability of your opponent holding a given card is equal to the number of copies left divided by the number of unknown cards. So the probability that Morgan might hold a 1 when there are 3 1s left and there are 10 cards, I don't know what they are, it's about a 3 in 10. But on the other side, there's informed probability. And this is also divided into 2 separate things. We have definite indicators and indefinite indicators. So definite indicators are sources of information where we know exactly what the opponent has. The 2 instances that we see here are the 2 and the 6. If you'll remember, when you play the 2, you get to see your opponent's hand. When you play the 6, you swap cards with your opponent. And so essentially, you know what their card is because you've just given it to them. And so what that means is that you know exactly what they're holding. And so we can say there's a 100% chance that my opponent has a blank at this time. And this is informed because we've learned extraneous information. The other side of this is indefinite indicators of informed probability. So this means we've played cards that indicate to us that something may be more likely, but it's not definite. So the cards in these cases are 7s, 3s, and 1s. If you play a 1 and you guess incorrectly, that's an indicator that they don't have that card. If you play a 3, or if someone else plays a 3, that's where there's a comparison. And so, for example, if Morgan were to play a 3 against someone else and the other person gets knocked out for having a lower card, then I would know that her card has to be higher than the card that was knocked out. And then 7s finally is the strangest of them all. And so if you'll recall, if you have a 7 in your hand and you draw a 5 or a 6, then you're required to play the 7. And so this means that if an opponent plays a 7, it's much more likely that they have a 5 or a 6, or an 8 as well, because you can't play the 8. But there are still instances when a player may play the 7 with a lower card. For example, if they have a 3-2, I believe, 3-2s means that the person with the higher card gets knocked out. So if you played that, you wouldn't want to be playing with a higher card, right, with a 7. So that comes out to about a 9/10 chance that the player is holding a 5, 6, or an 8, and about a 1/10 chance that it's a 1 through 4. And so what's happening here is that we're adjusting the probabilities that we already have from all sources of like definite, indefinite indicators, and just adjusting them so that certain ranges come out to a predetermined probability, 100%, 90%, 10%, to have a better estimation of what our opponent has. Secondly, our second level of AI is where we're deciding which card to play. Generally speaking, like we said, it's better to play the card with the lower value. If we get to the end of the game, the deck is out, you want to have the higher card. Of course, there are still special cases. So if we are reasonably sure about an opponent's card, for the AI, we gave it about an 80% probability that we know what an opponent's card is. Then you can do things like play a 1 and guess their card, play a 3 and compare, potentially knock them out. Play a 6 if you're sure that the opponent has a higher card, like an 8. You can play the 6 and swap hands and get the 8 to yourself, or play a 5 and make someone lose a higher card by discarding it. But of course, there are also general special cases, which is a bit of an oxymoron, but there are special cases, exceptions to the rule that we talked about, that always apply. So for example, with a high card, it might be a good idea to play a 3-1 because the lower card gets knocked out. And if you've got a high card, most of the time, the other player will have a lower card than you. The same case for 3-2, just with low card. If you have a 2 and a 1, it's generally better to play a 2, just so you can see what the opponent has before you guess, which is what the 1 does. And if you have a 4 and a 3, it's generally better to play the 4 because 3s compare. And if you have a 4, which is a middle range card, it's not necessarily a sure thing and you could lose pretty easily. And 4s give you immunity for the round. So it's always nice just to survive a little bit longer. And then finally, our last level of AI is where we're choosing an opponent. So once the AI has chosen a card, some cards don't require a choice of an opponent, like a 4 or a 7 don't require a choice, but all of the other ones do. And there's different methodologies between deciding which opponent to target depending on the card that you have. So if you have a 1, you want to choose the player that the AI knows the most about. Right, you want to guess what their card is, so the more you know about them, the better. 2s target the player that AI knows the least about. So if there's a player we haven't really gotten any information about, we want to look at their hand, see what they're working with. If you have the 3s, you want to choose the player that's most likely to have a high or a low card, depending on your variety. If you have a higher card, you want to choose a player that has generally a lower card. And similarly, 5s and 6s, you want to choose a player with a high card to either take it from them with a 6 or make them lose it with a 5. And so that's kind of what our AI looks like. And to round up this presentation, Morgan and I would like to do a little bit of a demonstration with an AI and hints, which functions very similar to the AI. So I'll be player 1, Morgan will be player 2, and player 3 will be the AI. So I'll go first. I draw a card. I have a 5 and a 1. I can ask the hint. Hint says that I play the Raven. Generally speaking, better play the lower card, right? So I'll pick Morgan, and I'll guess a 5. I was wrong. That's just how the game goes. So I'll give it over to Morgan.
Okay. That is, like he discussed before, not a good pairing. So I'm going to play the 4.
So what you just saw here is that the AI played and I was knocked out.
So if we look here, we can see what they played, and it looks like they guessed Andrew's.
Yes, so we can see the AI played a 1 and was able to correctly guess my card. I had a 5, so I was knocked out, and now it just goes back to Morgan.
So I'll use a hint here, and it's suggesting I play this one, which I'm guessing is because the highest value is knocked out, and I have a fairly low card. So I'll play this player 3, and there we go. I won.
So yeah, since Morgan had the lower card, the AI gets knocked out and Morgan wins the game. But you saw there already that the AI is able to make some pretty uncanny predictions, just guessing my card right off the bat.
Yeah.
So yeah, that concludes our presentation. If anybody has questions for us.
How'd you get the idea for this project again?
Morgan, why don't you talk a little bit about that?
We play a lot of games. Like when we were first like trying to decide what we were going to do, we discovered that we both like games a lot. And I played this game a lot with my dad, and I know that Andrew did with his too. And the theme kind of came from me talking back and forth with my dad. And there's a lot of different versions of this game out there, but we really hadn't seen like an Edgar Allan Poe one. So that's where that idea came from. It was just kind of, he's a really big person into literature. So
yeah, we had a lot of fun playing the game. Both of us have a lot of memories tied up with it. And for such a simple game, it's got a lot of depth, as we've talked about. So we had a good time making it, and that's kind of where it came from.
Okay, very good. Very interesting. Have you thought about how to, how to make this AI to be at different levels, say level 1, level 2?
Yes. So we've thought about that. Obviously, we didn't include it in our final presentation, but there are definitely ways to do it. One of the fun ways that I was thinking about is that if you remember back in the card choice level of AI, we said that if there's about an 80% probability that we know what a card is, then we'll play accordingly. And so one of the fun ways I think we could make an AI easier or harder is to change that threshold. So if we made it like a 50% chance that we know what the card is, obviously we could get a lot more wild guesses, and the AI could play a lot worse. Similarly, if we made it higher, it could also play worse, because if you have a 95% chance, how often are they going to
Actually guess.
guess well?
Mhm.
Because that's a lot of, you have to be pretty sure to be able to guess that high. So 80% was a general threshold that we chose to kind of
He's still pretty good.
make him pretty good. That's one of the ways we thought about doing it. And of course, you saw that the strategies we've talked about, things like always playing a 2 before a 1 or a 4 before a 3, we could take those out of the equation, so that maybe they're just following the rule of playing the lower card, which is not always the advantageous move. So there are components of the strategy that we could modify to make it easier or harder for the player, which is definitely something that's very doable and could help the game for sure.
Any other questions for our speakers?
I wanted to ask, kind of, because I have experienced CPS, obviously, and I know we have a very short time period to complete our research project. So if you guys had, a couple more weeks or even like a longer time period, what would you add to your game to, advance?
Yeah.
Definitely the difficulty thing.
Definitely the difficulty thing. Another thing that I'm not the happiest about is the way that we present the AI turn. So as you can see, as you saw in the demonstration, the AI, we didn't really get to see the AI take out their turn. And we just saw that I got thrown out because you guessed correctly. And that was something that would have taken us a lot longer.
Yeah, for sure.
But if we had more time, I think that's something I would have liked to add, that I would have added a lot to the project. And yeah, do you have anything that you would like to?
Well, as far as you said, seeing the computer player play, like I would like to have an option where you could see what they did, like what cards they had and everything. Or maybe just a record of all, like how the game went, so that you could like strategize again.
We tried to do that with the cards that have been played, but it would just be better if it was more visual.
Sweet, thank you.
So I think that's our time. Thank you everybody for coming and watching our presentation.
Thank you.
Yeah, thank you.